welcome to the third video of integration. In previous two videos we had seen the indefinite integration, then definition, what this integration means, then we had seen the different formula of integration, then in previous video we had seen the rules of integration, that means basic rule for integration. Now in today's video we are going to see the methods of integration. So broadly there are three methods. First one is integration by substitution, second method is integration by partial fractions, and third method is integration by parts. Okay, these are the three main important methods. Now let's see one by one. So the method one is integration by substitution. So this method is one of the most general method in practice. When the integrand is complex and not in the standard integrable form, we split the integrands in such a way that part of it, when substituted by another variable, the remaining part is the derivative of that part. So basically what you have to remember is that if question is like this, integral function of gx, and there we are having derivative of g of x. Okay, inside function we are having gx and we are also having the derivative of this function. If we are having function and derivative of function both in same integral, then we are going to use the substitution method. So see, for example, first example is integral sine cube x into cos x. So now we know that sine x, derivative of this sine x is cos x, right? So here it is a sine cube x, but we know that derivative of sine x is cos x and cos x is exactly here, right? So here we use the substitution method, right? So in this case, integrand sine cube x cos x, this is the integrand. We find that derivative of this sine x is cos x, okay, which is a part of the integrand. Hence we substitute sine x as t, and when we differentiate this sine x, we get cos x dx is equal to dt, okay, and we get this I as integral of t cube dt, okay, which is in the form of integral of x raised to n dx, and hence integral is t raised to 4 upon 4, but t is sin x. So finally I will get 1 upon 4 sin raised to 4x. Okay, this is the method of substitution. So just remember that if we are having integral function into derivative of function and derivative of function, if both are the part of integrand, then we apply the method of substitution. Okay, so now let's see the example. So first example says that evaluate integral x raised to n minus 1 into cos x raised to n. Okay, now we know that x raised to n and derivative of this x raised to n is n into x raised to n minus 1, right? So here x raised to n minus 1 is there in integrand, and that's why we substitute this x raised to n. Okay, so we substitute this x raised to n as t. So differentiating with respect to t, we get n into x raised to n minus 1 dx, that is equal to dt. Okay, see, we are substituting x raised to n as t, then we are differentiating this x raised to n with respect to x. Okay, so derivative of x raised to n is n into x raised to n minus 1, that is equal to derivative of t, Derivative of t is dt upon dx. So that means we are having n into x raised to n minus 1 dx is equal to dt. Okay. So that means x raised to n minus 1 dx, that is equal to 1 upon n into dt. Okay. So what I am going to do, I am going to substitute this x raised to n minus 1 dx as 1 upon n dt. Okay. So see here. Okay. So I is equal to integral cos x raised to n, but x raised to n is t. So cos t into 1 upon n dt. Okay. Now 1 upon n is constant, so it will become outside the integral. So 1 upon n into integral of cos t. And we know that integral of cos t is sin t plus c. So finally I will get 1 upon n sin t plus c. But t is what? T is x raised to n. So finally answer is 1 upon n into sin x raised to n plus c. Okay. So let's see one more example. Evaluate integral sin root x upon root x. Okay. Now we know that derivative of root x. Derivative of root x is 1 upon 2 root x. Okay, derivative of root x is 1 upon 2 root x. So I will substitute this root x as t. Okay. So let root x is equal to t. Okay, since derivative of root x is 1 upon 2 root x, so I will substitute root x as t. So what I will get? I will get 1 upon 2 root x dx is equal to dt. Okay, so that means 1 upon root x dx is equal to 2 dt. Right? So now I am substituting here. So 1 upon root x dx, that will be 2 dt. Then integral of sin root x, but root x is t. So integral of sin t dt. Okay. Now integral of sin t is minus cos t. So 2 into minus cos t plus c. Okay. But t is root x. So minus 2 cos root x plus c. This is the final answer. See next example. Evaluate integral cos log x upon x dx. Okay. So again we know that derivative of log x is 1 upon x. Hence we substitute this log x. So let log x is equal to t. So differentiating with respect to x, we get 1 upon x dx is equal to dt. So now I is equal to integral of cos t into this part is dt. So we know that integral of cos t is sin t. So sin t plus c. But t is log x. So final answer is sin of log x plus c. Then next example is integral cos x upon 1 plus sin square x dx. Okay. Here we know that derivative of sin x is cos x. Right. So we substitute sin x as t. So differentiating with respect to x, we get cos x dx is equal to dt. So integral I is equal to integral 1 upon 1 plus t square dt. Now we know that integral of 1 upon 1 plus x square dx is tan inverse x. Right? Tan inverse x plus c. So tan inverse t plus c. But t is sin x. So finally answer is tan inverse sin x plus c. Then next is evaluate integral 1 upon x log x dx. Again we know that derivative of log x is 1 upon x, which is there, right? So we substitute this log x as t. So log x is equal to t. Then differentiating this, we get 1 upon x dx as dt. Now integral is I is equal to integral 1 upon t dt, right? integral of 1 upon t is log t plus c, but t is log x. So answer is log of log x plus c. Okay. Then next is, see here, integral of e raised to x into e raised to x dx. Okay. Now we know that derivative of e raised to x is e raised to x, and that's why we substitute e raised to x as t. Then differentiating with respect to x, we get e raised to x dx. This whole term will be dt. Okay. So finally this term will be reduced as integral e raised to t dt. And integral of e raised to t is e raised to t plus c. Okay. But t is e raised to x. So e raised to x plus c. Okay. Then next is integral e raised to x into x minus 1 upon x square into cos square e raised to x upon x dx. Okay. Now we substitute this e raised to x upon x. Why? We are not having any direct integral of e raised to x upon x, but it is a complicated part. So as I told you in introduction, we are going to use this method of substitution whenever we are having a complicated term. So since it looks like a complicated, we use the method of substitution in this. So let's see, if we substitute e raised to x upon x as t, then when we differentiate this with respect to x, then we have to apply u upon v rule. So it will be x into derivative of e raised to x, which is e raised to x only, minus e raised to x into derivative of x. Derivative of x is 1 upon x square equal to t, right? So that means x is common. E raised to x is common. So x minus 1 upon x square is equal to, this is dt upon dx. Okay. So what I am getting? E raised to x into x minus 1 upon x square dx is equal to dt, right? And this is the exact term I am having in integrand, right? E raised to x into x minus 1 upon x square dx. Okay. So in first look it doesn't look like a derivative, but it is a derivative of e raised to x upon x. Okay. So hence I am substituting e raised to x upon x as t. Then differentiating with respect to x, so I am getting e raised to x into x minus 1 upon x square dx as dt. Okay. So now I is equal to integral of 1 upon cos square t dt. Okay. 1 upon cos square t will be sec square t. So integral of sec square t is 10t plus c. But t is e raised to x upon x. So 10 e raised to x upon x plus c. This is the answer. Okay. Then next is evaluate integral sec square x upon 3 plus 10x. Okay. So now I am substituting this 3 plus 10x as t. Okay. So differentiating with respect to x. So what I will get? 0 plus derivative of 10x sec square x is equal to dt upon dx. Okay. So sec square x dx, that is equal to dt. Okay. So this numerator part will be dt. So I is equal to integral 1 upon t dt. Okay. And integral of 1 upon t is log t plus c. But t is 3 plus 10x. So final answer is log 3 plus 10x plus c. Okay. Then see one more example. Evaluate integral dx upon x plus root x. Here I am taking root x as common. How? Now this x can be written as root x whole square, right? So denominator is actually root x square plus root x. So from this I can take root x as common. So I will get root x plus 1. Okay. So root x common. So I am getting root x plus 1. Now I am substituting this root x plus 1 as t. Now when we differentiate this, we will get derivative of root x as 1 upon 2 root x plus derivative of 1 as 0 dx equal to dt. That means 1 upon 2 root x dx equal to dt. That means 1 upon root x dx is equal to 2 dt. Okay, so this part 1 upon root x dx is 2 dt and this part is 1 upon t. So I is equal to 2. I will take outside the integral. So 2 into integral 1 upon t dt. So 2 into log t, right, plus c. But t is root x plus 1. So 2 into log root x plus 1 plus c. This is the final answer. Now see one more example. Evaluate integral sec square x upon 1 plus 10x into 2 plus 10x dx. Now here we know that we can clearly see that derivative of 10x is sec square x and hence we substitute 10x as t. So let's substitute 10x as t. So while differentiating with respect to x, we get sec square x dx as dt. So I is equal to integral of dt upon t plus 1 into t plus 2, right? Now here I am using the partial fraction method. So I am taking this part 1 upon t plus 1 and t plus 2. Okay, so partial fraction, so this can be written as a upon t plus 1 plus b upon t plus 2. Okay, then by partial fraction I will get the value for a as 1 and b as minus 1. So after finding this partial fraction I can write this as integral of 1 upon t plus 1 plus minus 1 upon t plus 2. Okay. Now integral of 1 upon t plus 1 dt, that will be log t plus 1, then minus integral of 1 upon t plus 2 dt will be log t plus 2, okay, plus c. Now we know that log m minus log n, that is equal to log m upon n. Okay, so log m upon n plus c, where m is x plus 1 and n is m is 10x, m is t plus 1 and n is t plus 2, but t is 10x. So final answer is log 10x plus 1 upon 10x plus 2 plus c. Okay. So with this I am concluding this third video. Thank you.